Hello friends, welcome back to my channel Tech-IOT. As from starting, you will feel bored sometimes. But guys, these topics are theory parts. I am trying to make it more impressive. But trust me, when we are going to practical part, you will feel it's amazing. None of any field is interesting more than IoT. So shall we move ahead with today's topic, IoT enabling technologies. IoT enabled by several technologies including wireless sensor network, cloud computing, big data analytics, embedded system. Wireless sensor network comprise of distributed devices with sensors which are used to monitor the environmental and physical condition. A wireless sensor network consists of end nodes, routers and coordinator. End nodes have several sensors attached to them. End nodes can also act as a router. Routers are responsible for routing the data packets from end nodes to the coordinators. The coordinators collect data from all nodes. Coordinator also acts as a gateway that connects wireless sensor network to the internet. Some of examples of wireless sensor network used in IoT: weather monitoring system, which the nodes collect temperature, humidity and other data. Indoor air quality monitoring system, which collects the indoor air quality and concentration of various gases. Soil moisture monitor system is used to monitor soil moisture at various locations. WSN are enabled by wireless communication protocols such as IEEE 802.15.4. Zigbee is one of the most popular wireless technology used by WSN. Zigbee specifications are based on IEEE 802.15.4. Zigbee operates on 2.4 GHz frequency and offers data rate. Cloud computing is a transformative computing paradigm that involves delivering applications and services over the internet. Cloud computing involves provisioning of computing, networking, and storage resources on demand and provisioning these resources as meter services to the user in pay-as-you-go model. Cloud computing resources can be provisioned on demand by the users without requiring interaction with cloud service provider. Cloud computing services offered to user in different forms: infrastructure as a service, platform as a service, software as a service. Infrastructure as a service provides user ability to provision computing and storage resources. These resources are provided user as a virtual machine and instance of virtual storage. User can deploy operating system and application of their choice on virtual resources provisioned in the cloud. Platform as a service PaaS provides the user ability to deploy application in the cloud using deployment tools, application programming interfaces, software libraries and services provided by cloud service provider. The cloud service provider manages the underlying cloud infrastructure including server, network, operating system and storage. Software as a service. Software as a service provides user complete software application or the user interface to the application itself. The cloud service provider manages underlying cloud infrastructure including server, network, operating system, storage and application software. The user is unaware of underlying architecture of the cloud. SaaS application are the platform independent and it can be accessed from various client devices such as workstation, laptop, tablets, smartphones running different operating systems. Since the cloud service providing manages both application and data, user are able to access application from anywhere. Next one is the big data analytics. Big data analytics defined as a collection of data sets whose volume, velocity or variety is so large that it is difficult to store, manage, process and analyze the data using traditional database and data processing tool. Big data analytics involves several steps starting from data cleaning, data wrangling, data processing and visualization. The underlying characteristics of big data include volume, velocity, variety. There is no fixed threshold for the volume of data to be considered as a big data. However, typically the term big data used for massive scale data that is difficult to store, manage, process using traditional databases. The volume of data generated by modern IT, industrial and healthcare system. Velocity is another important characteristic of big data and the primary reason for exponential growth of data. Velocity data refers to how fast data is generated from how frequent it varies. Modern IT industries and other systems are generating data at increasingly higher speed. Variety refers to the forms of data. Big data comes in different forms such as structured, unstructured data, including text data, image, audio, video, and sensor data. Some of examples of big data analytics is sensor data generated by IoT systems such as weather monitor station, machine sensor data collected from sensor and embedded in industrial and energy systems. Health and fitness data generated by IoT devices such as wearable fitness bands. Data generated by IoT system for location and tracking of vehicles. Data generated by retail inventory monitoring systems. Next one is the communication protocol. Communication protocol from the backbone of IoT system and enable network connectivity and coupling to applications. Communication protocols allow devices to exchange over the network. These protocols define the data exchange formats, data encoding, addressing schemas for devices, and routing packets from source to destination. Other functions of the protocols including sequence control that helps in ordering packets, determining the lost packets. Flow control that helps in controlling the rate at which the sender is sending the data so that the receiver or the network is not overwhelmed, and retransmission of lost packets. Here are the different protocols working on different applications. Next one is the embedded system. Embedded system is a computer system that has a computer hardware and software embedded to perform specific tasks. In contrast to general purpose of computer or personal computers which can perform various types of tasks, embedded systems are designed to perform specific set of tasks. Key components of embedded system including microprocessor, microcontroller, memory, networking units, input-output units, and storage. Some of embedded systems have specialized processors such as digital signal processor, graphic processor, and application-specific processor. Embedded systems run embedded operating systems such as real-time operating system. I hope you like my video, and if you like, then subscribe my channel. Thank you for watching. Take care. Bye bye. See you soon.